Yes, students, now before going any further, we have to understand how these fluids are going to behave with the shear stress or the rate of shear based on their relationship of shear and the rate of shear and the shearing stress. Sir Isaac Newton had devised a relationship. If the fluids that fluids follow this relationship, they are termed as the Newtonian ones. If they do not, they come under the non-Newtonian ones. Okay, so one by one we have to see this, and this is a very important concept to understand. I have mentioned that if the fluids actually follow a very simple relationship where the shearing stress has been found proportional to the rate of shear. If the fluids follow this one, this is termed as a Newtonian fluid. Okay, now this relationship based on the shear stress and the shear rate. Now if it is going to follow, if we plot the rate of shear, if we actually plot the rate of shear and the shearing stress for a Newtonian fluid, we are going to see a straight line graph. Very important from the exam point of view. When you are going to plot the shearing stress and the rate of shear, this is termed as a Rheologram. Okay, now this is a Rheologram for a Newtonian fluid. Similarly, if you plot rate of shear, if we plot rate of shear with a viscosity as a function of viscosity for a Newtonian fluid, then this plot is actually parallel to the rate of shear. So you have to understand this is now termed as a viscogram. Okay students, that was a Rheologram in which shearing stress was plotted with the rate of shear, and for a Newtonian fluid this is generally a straight line one. Okay, the slope of this straight line graph is termed as the fluidity. The slope of this straight line graph is termed as the fluidity. Very important students from your exam point of view. Okay, so now if the fluids actually follow this law, they are termed as the Newtonian ones, and if there is no direct relationship between the shearing stress and the rate of shear, they are termed as the non-Newtonian fluids. Okay students, now let's move on to the non-Newtonian part. Okay, now this non-Newtonian fluids, as I have mentioned, there is no direct relationship in this case, no direct relationship between the shearing stress and rate of shear. So that is why here the systems are categorized more into the time dependent systems or the time independent ones, or the viscoelastic materials. Okay, now in case of time independent ones, they may be classified into the plastic flows, that is the Bingham bodies, the pseudoplastic ones and the dilatant ones, while in case of time dependent ones, they are categorized into thixotropic, anti-thixotropic, 𝙭𝙬 systems, which are actually going to change their state upon the application of stress, and once the stress is removed, once the stress is withdrawn, they are going to return back to their original state. That is the action of the time, where they are put on to the situation of rest after certain force is withdrawn, then they come back to their original state. For example, gel to gel conversion or soul to gel to soul conversion. Ultimately, once the force is removed, they are converted back into their soul state or the gel state. We have to understand the only point that is the important here is the action of time. Okay, now let's see. Yes, so now as I've mentioned that in case of non-Newtonian ones, there is no direct relationship between the shearing stress and the rate of shear, due to which the fluids are categorized into the time dependent ones or the time independent ones. Okay, so one by one we have to see what are the time dependent ones or the time independent ones. Before that, as we have already mentioned, this was the Newtonian's law for the viscous flow of fluids, where we have seen that there is a direct relationship between what? Between the shear rate, shear stress and rate of shear. Okay, and this if do not applies, then it is termed as the non-Newtonian fluid. Okay, now in case of non-Newtonian fluid, firstly we will have to cover our time independent ones, which are independent for the function of time independent ones. These students, time independent ones, under these are firstly the plastic systems, which are also termed as the Bingham bodies. Okay, now in such cases of plastic systems, what is going to happen? Here you require an initial start, an initial force before the actual rheological flow can begin. So in case of such materials, here you require an initial flow or initial start just before the actual rheological behavior can come up. Okay, so now you can write here, we require initial force. Here we require initial force. Now this initial force will be termed as the yield value. Students, you should know this, that you should note it down. This initial force is nothing but the yield value before actual any rheological flow can begin. Okay, now from here you have seen the graph also. As I have mentioned, in the Newtonian one the graph will be straight line. In case of non-Newtonian one, you can see that the non-compliance of the Newtonian's law, like from the plot itself you can see that this is not in the compliance with the Newtonian's law. So the materials can be categorized into the time independent ones. Out of that we have been seeing the plastic ones. The plastic ones are actually the ones in which we require an initial force before their actual flow can begin, actual rheological flow can begin. Okay, so in case of each type we have to see the individual rheograms also. Okay, so for the plastic fluids, if I plot a rheogram between the shear stress and rate of shear, we have mentioned in case of the plastic ones, there we require an initial force which is termed as the yield value. Okay, so this right here, this is the yield value, which is the initial force required so that any actual flow can start. Okay, this is in the case of the plastic systems only. Okay, students, I hope you have got my point. You can see the plot and you can see the yield value. Okay, so now we have to understand that what actually happens in this case. Here I'll explain it with an example. Suppose these are the materials. Okay, now here you just, in order to make them flow, in order to start their rheology, you have to apply a certain force which is equivalent to the yield value. Okay, due to which these particles slightly loosen up, their forces of interaction try to break, and on applying further stress, they are easily going to flow. Okay, so this is the difference between the plastic flow, which is actually exhibited by the concentrated suspensions. Very important, students, you should note the example. The question can directly come from the examples only. Very important, you should know the concentrated suspensions. Example of the plastic flow is the concentrated suspension. Mark it, really important from your exam point of view. I can bet you, students, either you are asked on the type of flow or the example only, but you should understand the concept behind it, because ultimately you are going for a master's course or a higher degree course where in pseudophysics or in any stream that you choose, or either the ecology, the cognosy, you are going to study the interdisciplinary approach, where you have to take all the basic concept from all the fields, and you have to apply it when you will do the research. So anyways, the concept is really important to understand. Secondly, from the exam point of view, you should know that from where the topic, from which topic and from which part of the topic the question can be raised. Okay, now I have mentioned it is usually the Bingham bodies, which are the plastic ones. This question can be asked. What is this yield value? This question can be asked. And most important is the example or the rheogram that can be asked. Okay, so now this was your plastic ones. Now you have to see the second ones. The second time independent ones is the pseudoplastic ones. Okay, first was the plastic, now comes the pseudoplastic. Now in case of pseudoplastic, this is also termed as a shear thinning systems. Very important from exam point of view. Shear thinning systems are the pseudoplastic ones, right? Now in these systems, actually what happens, please students note it down. In these systems, these material tend to become more fluid the faster they are stirred. Okay, now as you increase the stirring, they are going to become more into the fluidity part and they will flow easily. Okay, as I mentioned previously, the example was what? The concentrated suspensions. In shear thinning system, the example is the polymeric solution. Very important from your exam point of view, polymeric solutions. Okay students, very important. Now polymeric solutions of what? Of gums, of tragacanth, of sodium alginate. Okay, all these come under with the polymeric solutions are the example of the pseudoplastic systems or the shear thinning system. Now as I have mentioned, as far as the topic is concerned, the question is directly asked which among the following is the represents the shear thinning system. So you must know the pseudoplastic ones represent the shear thinning systems. Okay, now seeing the rheogram, what actually it looks like, we know that rheogram is what? It is the plot of shear stress and the rate of shear. So in case of plastic ones, we have seen that they require an initial start, which is the yield value. In case of this, the graph actually starts from the origin. You must see the difference. This is for the pseudoplastic ones. Okay, that was for the previously that we have seen, this plot was for the plastic ones. Okay, very important, the differences in the plot can be seen. So here you can see the rheogram actually begins at the origin. The rheogram starts from the origin itself, and the reason could be because of the weaker particle interaction, they are not even able to withstand the shear that has been applied. So that is why with the increasing the shear, increasing the stress, the graph shifts to more of a concave shape. Okay, very important point, students. I've mentioned already that in case of plastic, that it was required an initial force to actually begin with the rheological property, but in case of the pseudoplastic ones, what happens, it starts from the origin only, and then you have to, then the graph shifts to more of a concave part. The reason behind it, that the particle interaction might be very weak, that it is not even able to withstand the amount of shear, amount of stress that has been applied. Okay, so the rheogram becomes more of a concave shape in case of the pseudoplastic systems. Okay, now the third type of systems that we are going to discuss is the dilatant systems. Okay, students, now as mentioned with word, dilatant means they are going to dilate, they are going to expand, they are going to increase in their volumes. Okay, such systems are termed as the dilatant systems. Example for such systems includes the suspensions that actually contains deflocculating agents, suspensions that contains deflocculating agents. Okay, students, and now we have seen in case of plastic material how this rheogram was made. In case of pseudoplastic material sorry, also how this rheogram is maintained. In case of dilatant systems, students, you should see here the shear stress and the rate of shear when plotted. These are plotted like this. Okay, this represents the dilatant systems. Very important. Okay, directly a question can be asked. One more point, we have seen that the pseudoplastic systems were the shear thinning systems, but the dilatant systems are the shear thickening systems. Okay, students, very important, shear thinning systems and shear thickening systems. Okay, you should know the difference between them. You should know how the examples vary, how their properties are going to vary with the stress that is going to be applied. You can see with their rheograms also how these differ from each other. Now these all were, students, the time independent systems. Okay, so summarizing in brief, we have seen till now the non-Newtonian fluids are the substances which do not obey the Newtonian's law. Okay, they are categorized, they do not have any direct relationship between the rate of shear and the shearing stress. Okay, there is no direct relationship between them, but yes, they are further classified into the types of flow, including the plastic ones. We have seen their rheograms also. Very important from an exam point of view, that they are the Bingham bodies also exhibit the plastic flow. Very important from your exam point of view. G part. Okay, the pseudoplastic ones and the dilatant systems. The pseudoplastic ones is the shear thinning systems. Okay, and the dilatant ones is the shear thickening systems. Okay, students, very important. This right here, this slide is very important. In case of plastic ones, we have mentioned the concentrated suspensions as the example, which might include also ointments. Okay, in case of pseudoplastic, we have mentioned the polymeric solution. Polymeric solution of what? Gums, of tragacanth and 𝘿𝙎𝙎. Okay, and the third one is the dilatant. The example of the dilatant we have mentioned, these were the shear thickening systems. These are exhibited by the deflocculated suspensions. Okay students, very important. This slide here that I have written here is very important, and the rheograms that we have seen are also very important from your exam point of view. Okay, so now summarizing them in little brief, we can see here that we have already discussed the plastic flow, where material does not begin to flow until a shearing stress, which is the initial force that is required, which is termed as the yield value, before the actual flow can start. These are associated with the flocculated particles in the concentrated suspensions and emulsions, with the examples of ointments, gel, cream. These show the plastic behavior, very important from your GPAT point of view, these examples. Okay, so now in the graph also you have seen the rheogram, where how this Newtonian fluid is plotted. Okay, this plot was termed as what? Fluidity. Okay, the slope indicates fluidity. Now we have seen the plastic ones. You see, we have here also we had made this type of rheogram, where this initial force is required, y, which is equal to the yield value, before the actual rheological property can start, flow can start. Next is the pseudoplastic ones, where we have seen that the rate as the shear stress increases, the viscosity decreases, the molecules are disarranged, they begin to align with their axis actually. Now the pseudoplastic ones, we have seen in the pseudoplastic ones that these molecules are actually going to become more of a fluid as faster they are stirred. Okay, the example being the polymeric solutions, including the synthetic gums, the tragaguns, the sodium alginates. Okay, next is the dilatant flow. In case of dilatant flows, these are very much opposite to the pseudoplastic ones, where the materials are which tend to expand, they tend to dilate, they tend to increase in the volume. Example of the following is the deflocculated suspensions as mentioned, and the magnesium magnema. Very important guys, from your GPAT point of view students, please mention these examples are really important. These rheograms you see is very 5-star important from your exam point of view. Okay, good. Next, these were the time independent systems. Okay, now we have to see what the time dependent systems hold for us. I have mentioned in the start also, for the time dependent systems, they're actually the interconversion between the state of what they had been after the influence of stress, and after how the force, if withdrawn, in which state they now come. Okay, so one by one we have to see. First that you have to study is the thixotropy. Very important students, I'll mark those points into star, from which the questions can be asked directly. Okay students, so first is the thixotropy. In case of thixotropy, the conversion is from gel to sol and then to gel. Gel, sol, gel conversion. Okay, now this is defined as what? This is defined as a time dependent breakdown or what? Rebuilding of structure upon standing. Okay students, very important. This is a time dependent breakdown. One important other thing that you should know, it is a reversible phenomena. It is a reversible. As we can see, the gel particles are converted to sol and the sol is then converted to gel. With an example of bentonite, very important from exam point of view. Bentonite gel, which is actually 8% weight by weight. Okay students, now you might be little confused that I have just mentioned the details but I did not explain the science behind it. Okay, so now I am going to explain you a very simple thing out of which you will be able to understand how this gel-sol-gel conversion occurs. It is a time dependent phenomena, and how this bentonite gel is going to behave, and how it is a reversible phenomena, right? Suppose I'll give you an example here. Yes, let's suppose you have a gel substance here, gel material here. Okay, now you apply shear stress on it. You have a gel material on which you apply shear stress on it. Now you convert it into another state, that is the sol state. Okay students, now you remove this stress. Now you remove this stress. Okay, what happens is this gel sol gel is converted yet into a gel system. Okay, but the point is the time dependence. Okay, upon keeping it for some time, when it is converted into gel, this is termed as thixotropy. Okay, time dependent conversion. This is the thixotropy. This is a slow process that is happening here. Okay, there are methods due to which we can increase or fasten this process by adding vibration, by adding mild turbulence. Okay, so by adding vibration or turbulence, this conversion gets a little faster. Now this is termed as 𝘂𝙎𝙎𝙎𝙬. A lot of students get confused that how these thixotropy and 𝘎𝙎𝙎𝙎 are different from each other. Now you can see in a very simplified manner that yes, both holds a similar type of conversion from gel to sol and then back to the gel. This is a time dependent breakdown, but the rebuilding of structure occurs upon leaving them for some time. Example, how this bentonite is going to behave. It is in a gel form. When the shear stress is applied, it is converted into the sol form. Now upon when we remove this stress, it is again converted into the gel form. Now this process is a slow process. If this happens like that only, this is termed as thixotropy. But for fastening this process, for making it a little faster, mild turbulence and vibration is supplied. That is termed as 𝘎𝙎𝙎𝙎𝙎. Students, this is very, very, very important. Very important. Okay. Second is the opposite of it, that is anti-thixotropy. Anti-thixotropy. Here students, now we have to see what type of conversion take place. In thixotropic systems or the 𝘎𝙎𝙎𝙎𝙎 systems, you know there is conversion from gel, sol, gel. But in anti-thixotropy, the conversion is from sol to gel and then to sol. Okay, sol, gel, sol conversion occurs in case of anti-thixotropic system. This is also a time dependent breakdown or the rebuilding of structure which occurs upon standing. Okay students? Yes students. Now on the anti-thixotropy part, we should know that it is a conversion from the sol to gel to sol interconversion. Okay, now as we have seen in the thixotropy that the gel sol gel conversion, if it occurs slow with the slow process, that is the thixotropy, and if the vibrations or the turbulence is provided, it is a better and faster process. Okay, in case of anti-thixotropy, what happens? You should write it is also a reversible. You should understand this is also a reversible, time dependent, but here is what? Increase in the viscosity, time dependent but increase in the viscosity at a particular rate of shear. Okay, so now let's understand this Sol state here also. It is converted into the gel state by the application of shear stress. Okay, just like in the previous one, but this gel state is converted yet again into the Sol state. But this process, if it is a slow process, this is termed as anti-thixotropy. This is termed as anti-thixotropy. But once this process can be fastened yet again with the help of these vibrations or the turbulence, then it is termed as the negative 𝘎𝙎𝙏 system. Very important, students, from the exam point of view. The anti-thixotropic system, Sol gel Sol conversion with the help of vibration, if it is happening, it will be negative 𝘎𝙎𝙏 system. Okay, very important from your exam point of view. What we have discussed, I shall summarize that thing in little detail. Okay, we have just discussed two sections. One that converts what? That converts gel Sol back to the gel to Sol conversion upon the application of stress. This Sol is converted if with the slow process. This is a thixotropy system in back to the state of gel. Okay, now if a vibration is provided or the turbulence is provided, it is converted back to the gel state but with a much faster speed. This was the thixotropy system. This is the 𝘎𝙎𝙏. Okay, students, similarly the other one that we have discussed is the Sol to gel conversion upon the application of stress. Now this gel is converted further into the Sol with the slow process that will be termed as the anti-thixotropy or the negative thixotropy. Okay, if a mild turbulence or the vibration is provided, this is converted to Sol, but this process will be called as negative 𝘎𝙎𝙏. Very important, students, from your exam point of view. Very important. Okay, so you must note down this summary of what these materials hold. We have seen the example of the thixotropic systems. We have seen the example of the thixotropic systems as the bentonite gel. Okay, very important example. And the example of the anti-thixotropic systems, we have to mention that yes, they convert from Sol to gel to Sol. The anti-thixotropic systems includes the example of magnesium magma. Very important. Okay, now before going further, we will just have a quick reading of what is being written here. You can see we have mentioned the thixotropy is gel Sol gel conversion. It is applied to shear thinning systems, yes, because they actually break down the structure and are not reformed immediately. But yes, once the stress is removed, the rebuilding occurs very slowly. This is the thixotropy. But if you apply the vibration, that it is termed as the 𝘎𝙎𝙏 vibration or any turbulence also. Okay, in case of anti-thixotropic system, you should note down the example, students. The example of thixotropic system I have mentioned was the bentonite, and in case of anti-thixotropy was the magnesium magma. Okay, in such cases, okay, the Sol gel Sol conversion takes place. In the Sol gel Sol conversion, what happens, that initial stress is applied, then converts the Sol to gel. Then if the gel is formed, this formation into again Sol, the restoration will take place slowly. That is the anti-thixotropy or the negative thixotropy. If it is converted fastly with the vibration, it is termed as negative 𝘎𝙎𝙏. But here you should know that earlier it was the Sol state, that was the low viscosity state. Then here it should be mentioned Sol state. Then converted into a high viscosity states. Then again it is converted into a low viscosity state. Okay, the individual particles there were large in number although, but they were in small flocks. Okay, now with the more of the interparticle interaction has been increased, the contact has been increased, they are supposed to have a high viscosity in the gel state, then these contacts actually break and then converted into a low viscous material. This was all about your time dependent systems. Okay students, one more topic that is very important from an exam point of view is the determination of viscosity, which is done using the viscometers. Okay, the viscometers can be divided into the single point ones and the multi-point ones. You should know that the single point ones are based on the Newtonian ones and the multi-point ones are based on the non-Newtonian ones. Okay, the examples are really important from your exam point of view. The single point comes, we can write a trick for that is SOF. You know the fennel seeds, right? So, the fennel seeds in Hindi are known as SOF. So you can remember that is as SOF. SOF in this S is the single point. Okay, O is the Oswald viscometer. This F is the falling sphere viscometer, very important. Okay, then is the multi-point one. You can memorize as MCC. MCC in M is the multi-point one. C is the cup and bob, and other C is the cone and plate. Students, you can get direct questions out of this topic. Please do not miss this topic. Please memorize it daily. Make the tricks. Answer the questions that I asked. Focus on the concepts. Focus on the points that I have mentioned that it has came in your exam also. Okay. Next, here are some questions. Here is some important points first, then we will move on to the question part. First is the viscosity. What is viscosity? It is the property of liquid, which is basically the resistance to flow. You should know the unit, that is the poise or the dyne into second per centimeter square. Very important. From this topic, I can bet you that direct questions will be asked. Okay. Now, direct questions will be asked from this point where the viscosity, which is the property of liquid which offers the resistance to the flow, the unit will be the poise or dyne into second per centimeter square. Second is the fluidity, which is actually the reciprocal of the viscosity, and obviously if the unit of viscosity was poise, it is supposed to be poise inverse. Last and very important is the kinematic viscosity. Make it 5 star. It is nothing but the ratio of the absolute viscosity upon the density of liquid. Very important. It is the ratio of absolute viscosity upon the density of liquid. The unit for the same is the Stokes or the centistorm. From here only a lot of questions will be asked. So please try to memorize them as much as possible, especially the kinematic viscosity one. Now we will move to the questions part. I hope you will be able to answer these questions right away. Okay, so the first question is which instrument is used for the determination of shear rate or shear stress? The options are the ultrasonifier, the rotational viscometer, the oscilloscope or the chisholmometer. I must say, if you have just seen this video, you have a very little brief knowledge of it, you can answer this question very easily. I hope by now you got the answer. It is the yes, rotational viscometer is the correct answer to this question. Okay. Next, following gel shows a thixotropic behavior. Very easy question. Options are bentonite, starch, pectin and silica. I'll just give you a few seconds so that you can write the example, you can write the answer below, and I hope you get the right one. Okay. So yes, now we'll discuss the answer, that is the bentonite. Very correct. If you got it correct, you might remember that I have mentioned the example in the thixotropic systems that the bentonite gel, which was 8% weight by weight, was converted from gel to sol to gel. Okay, this process was actually slow, so that was termed as the thixotropic process. Okay, I hope you all have got this right. Next question. Pseudoplastic flow is exhibited by emulsions, polymeric solutions, suspensions and ointments. I'll give you few seconds to write the answer. I hope you all can get it right. I'll just be writing here the other ones so you can get the time for it. Please write the correct answer. I had mentioned that these examples are really important. I had mentioned in case of plastic systems was the flocculated suspensions or the emulsions or the ointments or the creams. So here, yes, this option is wrong. Emulsions get wrong and the ointment gets wrong. The correct answer is the polymeric solution. I have mentioned the polymeric solutions of basically Tragogunt can be the one, the gums can be the one, the alginates can be the one, the CMC, sodium CMCs can be the one. Okay, right. Next, in dilatant systems, the example was the deflocculated suspension with example of magnesium magma. Okay, so these were all the important topics that I had mentioned that question can be asked from any of these topics. Okay, so correct answer is yes, polymeric solution. Okay, next question. Thixotropic phenomena can be applied to dash system. Right, today in this slide we have seen this answer. It is shear thinning systems, or is it shear thickening systems, or it's both of the above, or it's none of the above. I hope you all get it right. Yes, it is the shear thinning system. I had just shown you right here. I'll just show you the slide. Yes, here I have mentioned that yes, thixotropy is applied to the shear thinning systems, which are the pseudoplastic ones, and shear thickening systems are the dilatant ones. Okay, next question. Yes, last question. Bingham bodies show which type of flow? Is it the Newtonian flow? Is it the plastic flow? Is it the pseudoplastic flow? Or is it the dilatant flow? I hope you are going to get this very easily. All these questions have been prepared from your last year questions, from your different books. These questions have been asked on a repeat mode. Okay, so first option, Newtonian flow, is directly incorrect because Bingham bodies do not belong to the Newtonian systems. These belong to the plastic systems. Okay, not in the pseudoplastics and not in the dilatant. Both three of these come under the non-Newtonian ones. Okay, but the correct answer is B, plastic flow. Okay, so students, I hope you have enjoyed watching this video. You had a great time learning. You have got an idea of the important topics that can come in your exam, the parts from the topic which are really important from your GPAT point of view. So I hope you will now be able to buckle up the preparation and score the best out of what we have studied. Okay, so thank you so much, students. We'll meet in the next class.